All right, let's look at a couple more of these examples. You can see we have the x's fading out as the y's fade in on this trinomial, so we can again use that same technique as we just saw in the previous video. We want to look for m times n, m and n, such that the product is 20 and their sum is 9. So m times n is 20, m plus n is 9. Let's see, 1 and 20, 2 and 10, 3 doesn't go into it, 4 and 5. 5 is already taken, so we've already done the entire list. There's our sum of 9. So this should be x plus 4y times x plus 5y. Again, just using the 4 and the 5 there, tacking the y onto the second term allows us to have it match this up here. All right, if we wanted to factor 2w plus w squared minus 8, this is not in standard form. So the first thing I'd want to do is rewrite it so that it's in standard form. W squared plus 2w minus 8. Now that it's in standard form, the coefficient of 1 here, and then so x squared plus bx plus c is how I referred to it before. Of course, it doesn't have to be x's it doesn't have to be x's. But we want the product to be negative 8 and the sum to be 2. So 1 and 8, 2 and 4. We want the product to be negative, so let's try this. Looks like that's a sum of 7, that's a sum of 2, that's the one we're looking for. So we get w minus 2 times w plus 4. And on this one, again, it's not in standard form. Our degree 1 term is written last, so we want to do rewrite it. Y squared minus 12y plus 35. So we want the product of our two numbers to be 35. We want the sum of the two numbers to be negative 12. So the product of 35 we can get with 1 and 35. 3 doesn't go into it. 5 and 7. Looks like those are the only ways we can do it. We want the product to be positive, but the sum to be negative. So since the product is positive, they're either both positive or both negative. The fact that the sum is negative means that we're actually looking for this case right here, negative 5 and negative 7. So negative 5 times negative 7 is positive 35, and their sum is negative 12. There's never going to be multiple choices when you're doing this. I mean, you could do negative 7 and negative 5. There's nothing special about the order I'm writing these in. You'll see I did w plus 4, w minus 2, then w plus 4. There's a commutative property of multiplication, so I could have done w plus 4 times w minus 2, and there's no standard form for writing the order of those factors. But other than rearranging the order, this is the only way we could write that particular factored form.